Looks like the mic's working. So today we're going to do something a little different. We're going to work on fixing the SLA 3D printer because it has a homing issue now where when you try to home it, the Z-axis just grinds against the plate because it can't find home because the Z limit switch isn't being triggered properly. And this is likely due to this addition I made to the build plate, which is, if you look close, you can see this brown layer here, and then this top metal layer here. This is a magnetic plate so that it can be removed easily. Sorry. A little bit of resin on there. Don't want to touch that stuff. So what the issue seems to be is that the thickness of this addition is just enough that the trigger for the Z-axis limit switch isn't being hit. So the printer's over here, and I'll show you what I mean. Here's switch seams. Alright, we're going to have to power it on and lift the Z up a bit. Maybe a little bit higher. Alright, see if we can get the camera in there. Can't really make the camera go much lower, but you'll see right here, this little plate that sticks down, it hits a trigger down at the bottom here, which is what tells it to stop. And so now what's happening is the base of this plate is not reaching here. So what we're going to do is take this off, and to do that it's just 2 Allen screws. I'm going to cover the screen so that if I drop the key or this piece it doesn't hit the screen. One of 2 removed. And so essentially what we want to do is just make this plate right here sit a little bit lower, just at the thickness of that addition to the build plate. So first things first, we're going to have to take some measurements. Let's see. So I'm going to use our calipers. I'm just going to measure how big this is. Okay. So it's about 14 by 10.5 millimeters. What's up, Pixies? Is the audio coming through all right? You made it. Glad to see you here. Even though I see you upstairs too. Alright, so we're going to use Fusion to do this. So let's see, the chat's going to hide behind this window so I won't see it for a second, but I'm going to create a sketch. So what we're going to do is print this spacer that we need. We're just going to create a rectangle, and we're going to make it 14 by 10.5. And we could even round the corners off a little bit. Let's just make that like a 1mm flange. Next thing we got to do is figure out how big these holes are. Just measure those up real quick. And they are about 4mm. And because we'll be printing this on an FDM printer, we want to compensate for a little bit of slop on that, usually about 0.15mm. So we'll make these holes about 4.15, and we got to see how far in they're offset from the edge, because one edge is a little uneven from the other. Let's see, that's the easiest way to do this. Okay, it's set in about 1mm from the edge, so we can just make a line 1mm in, and then we'll use that as a guide and extend this all the way over. We want the circle to be a 2-point. We'll start from where that 1mm marker is, make it 4.15. Actually, that's gonna throw it off a little bit. Let's just do the 4. I think it'll be fine. Let's measure those screws first, because these look like they're probably M3 hardware. So if we measure that up, oops. Yeah, we only need it to be about 3.25mm, so 4 should be fine. That way we don't have to guess about the distance of the other inset here, which looks like it's going to be, let's do this. About 5mm in from the edge, from the same edge. So we'll set this circle here. We'll do another 5mm line. Oh, that's not going to work out. Mathing is fun.
Wow.
It's actually got to be about 7. And then we will make another 4mm circle, 2-point. Let's just check chat. Jonathan, what's up, buddy? How you doing? Welcome back. We're doing something a little different today. Trying to make a fix for one of my 3D printers. Oh, and you know what? Before we do that, let's change that to guideline. So it is a little bit offset, and that's how it looks if you look at it. Here, let's see if that's in focus. Hold on. So that's essentially what we're trying to offset, and we want it to offset the thickness of this brown piece of the plate, including the top plate there. So let's measure that up too. And that's 3mm. So that's how far we're going to extrude it. Cool, buddy. Yeah, thanks for being here. Thanks for checking it out, even if it's just boring stuff. So now that we're finished with the sketch, essentially we just want to offset this piece 3mm. So we're going to extrude that. I am not a CAD professional by any means. I just Kind of learn as I go. That looks about right. Hopefully this is all we need. So, I've got to save this first. Oh, got to edit some shit real quick. Make this read only. Just using the free version right now, so I can only save so many projects at one time that are editable. We'll call this SLA printer Z offset. And that goes in here. Alright, now we should be able to export this as an STL file. Create a new folder for that. Saver. Looks good. Hopefully this completes. Sometimes it doesn't. In the meantime, I'm going to fire up the FDM printer, get it all warmed up. Alright, looks like that completed. So let's pop the card in. And then let me switch this view over real quick. Now we're looking at Cura, which is the slicer I'm going to use to turn this into G code. For whatever reason, I cannot find my folder in here. Interesting. One second. Oh, I'm looking at the wrong directory. That's going to explain it all. Alright, there we go. So we'll just drop it on here. Bar she blows. Check our print settings, don't need supports. Skirt should be fine. We'll slow this down a little bit. Set to the under 5, should be good. And fill, we'll just do 100 on this, since it's tiny. I think that'll be fine. So what I'm trying to fix here, Jonathan, is on this SLA printer over here. Let's see, let me make sure you can see that. I don't have multiple things going on, but On this Anycubic printer here, I have added an addition to the build plate. So I added this magnetic plate that is removable, and the thickness of this is preventing the Z limit switch from triggering. So when you try to set it home where it finds like the base area, it just lowers this down until it hits the Z axis limiter switch. The trigger for it is not actually being hit, which is triggered by this piece here, which just attaches on in here, and it's supposed to come down, and I think it goes this way actually, come down and like trigger that switch, but it's sitting too high now because what's happening is this base plate is hitting the screen before this is hitting the trigger. So what we're trying to do is just create a little offset for it so that it'll stick down just a little bit lower, just the thickness of the addition on that plate, and hopefully trigger the Z-axis limit switch without any issue. It's the nice thing about 3D printers, though, you know, you can engineer your own solutions for them. Alright, let's get back to Cura. It's only going to take 4 minutes to print. So we'll save that. Need to eject the disk real quick. And then I guess we'll see if we can put an extension on this USB cable, so we should be able to like actually watch it print. Just switch the camera view. Glue it up a little bit. Should be leveled. I should probably check it, but that takes more time than I want to spend, honestly. Insert the disc, initialize the card, find it on the card. Got too many things on this card. Still looking for the file. Still looking. Okay. Maybe I didn't get it on there. Let me try again. Okay, it's definitely on there now. Let me try again. There it is. Print it. Should you buy a 3D printer? Well, I mean, if you're into prototyping, you're into fixing stuff, or you just want to make cool things, yeah, you should buy one. As far as cost, I mean, cost varies quite a bit. A printer like this is the Ender 5. by Creality, and when I bought this one, which they've got upgraded models of this now, I bought this like 4 years ago. It was probably about 350 bucks, but I will say this has been my most reliable printer. The reason I like this one so much is because of the whole setup you got here with the frame, where the print head is the only thing that's moving, right? It seems to create more reliability and robustness in the printer as, say, compared to the one that's over here. This is the Ender 3. This one's what you would call a bed slinger, so the bed actually moves back and forth, and then the print head moves left and right and up and down. I've had a lot more problems with this one than the Ender 5, and this is way newer, but this is also substantially cheaper. So this printer, I think you can get to start around 150 to 180. And then the one we're fixing is an SLA printer. It's a different type of printer altogether. It's a resin printer versus an FDM. So this is what's called SLA, stereolithography. These are quite a bit more involved to work with, and quite a bit more expensive. That printer, with all of the stuff to use it, which is all this stuff over here, including the enclosure with the ventilation, which you can see runs out the window and everything, and then the wash and cure station, it cost about $1,000 when I got it. So I'd say if you're going to start out with something like this if you can afford it, and if you can't afford it, try something more like the Ender 3, and just get like a bare bones model, so it's not going to be too expensive, and that way you can figure out how it works and troubleshoot everything that you need to troubleshoot on it before you start adding things to it, and because that makes troubleshooting a lot more complex than just, you know, a stock printer. And these things will work right out of the box pretty much. You want to see it from the top? Let's see if we can get a view of it. Can't really see it because it's going to be underneath the print head. I could lower it down so that it looks into it a little bit better. Let's see. It's about as close as I can get it. And this isn't a great camera, so sorry about any focus issues. I'll tell you, man, I love 3D printing, and CAD isn't that hard to use for basic stuff. There's tons and tons of tutorials on YouTube and online. You can look up pretty much anything you need to know about how to make anything. Well, I use it all the time for, you know, making toys for the kids, or fixing stuff that breaks, or just prototyping new things that I'm interested in cultivating, you know. How long does it take to print? It all depends on what you're printing and how you're printing it, right? So when you saw in Cura all the slicer settings we were setting up, those settings are what are going to dictate the print time. So you can change a lot of aspects about it, about how it prints, right? Which is essentially what Cura does, is it slices it into layers and then tells it like what the tool path should be. So it's telling it how to move this print head around, basically. And you can see this piece that we just made only took about 4 minutes to print. That's pretty forgiving, right? But bigger stuff, you know, is going to take longer. The more infill that you have, the longer it's going to take. The more need for support structures you have, the longer it's going to take. So there's a lot of factors involved in print time, and you kind of just learn as you go. You know, like if your print time's too long, you're just trying to prototype something, you might just end up throwing away. You know, you can always adjust your settings accordingly. And here's our piece. So let's see if the measurements came out right, and if we can install it. Alright, let's see. What's my longest print? I've had some take about 12 to 15 hours. Depends on what you're printing though. A lot of stuff, you know, bigger stuff is going to take a lot longer. I've had the slicer tell me certain prints were going to take, you know, up to 3 days. But again, it all depends on what you're doing and how you're doing it. So now we're going to check the fitment with the piece and see if it lines up. It's practically perfect. You can see right through it, which is exactly what we want. So we'll just thread the screws through it and see if there's any resistance or anything. Alright, so we do have a new problem. The new problem is that the screws go through it, but they don't come out the top enough to actually thread into the machine, so might have to find some bigger screws for this, which I have a bunch. Yeah, seems not to be an issue. It's coming through. So if you do get into 3D printing and prototyping stuff, I recommend buying something like this. This is just a box of like various assorted screws and stuff for issues like this, right, where you might need a different size because now the fitment is just slightly different. So if we look at how long this guy was, let's see, I've probably got some in here that are about the same size. So then we can just step it up a little bit, so we'll just step it up a little bit like that, maybe another millimeter. Let's see how that fits. So that should work out, I hope. But just to see, let's measure how far that sets up from there. Looks like it's about 3 millimeters off the top. So if we take that piece off that we just made and put the old screws in, let's see if it's about the same. They actually set up about 4 millimeters, which, let's see what sizes these are. So we're using the 8, and the only other size we have close to that is the 10 millimeters. So that would put it up about 5. I'd rather have it a little too short than a little too long. Oh yeah. I don't know if you want to look at my ugly mug that close, but this should work out now. So we'll switch over to the printer over here and see if we can install it. So let's bring her over here. reason I got this box here is because if I drop anything, I don't want it to land on the screen. Alright, so this has got to fit up in here, just like that. Let's see if we can get one started. Should be good. Get the other one started. We don't want to do it too tight yet. Because we want to see if it's going to actually line up with the sensor the way it's supposed to before we tighten it down too much. Alright, so now we'll turn it on. Let me just adjust the camera angle a little bit. Move it over so you can kind of see what I'm talking about. So if you look right here, this little gap is what this piece is supposed to... let me lower it down actually. Gotta wait for it to boot up. So you can see this piece that we just installed here that's moving down, this black piece. That's going to line up inside of here. So we're just going to get it down there close to it. Now I'm just going to see if it looks straight, and it does. So now I'm actually going to put it back up a bit and tighten those screws down. Come on, go up. Recover the screen here. Come on, move up there. Tighten them down a little bit. Should be good. Alright, so I'm not going to put the build plate on to check this. I just want to see what we're looking for here is when I home it, it's going to try to go all the way down to where it thinks it should stop, and we're going to hope that it stops where it's supposed to instead of trying to keep going. Oh, but you know what? I actually will have to put the build plate on for that. So let's just put that on. Let me go get my leveling sheet real quick. Alright. Now we're going to hit home and hope for the best. I'll cancel the home or turn it off if it starts to grind. Perfect. Alright, that fixed it. Now we might actually be able to use this printer. Sweet, I'm stoked about that. Cool. Alright, so if we want to finish the leveling process here, grab the Allen wrench. Oh, I'm so glad that worked. I was stressing out about this. Me and my buddy want to get making and painting mini figures and stuff, and I was just afraid that this was going to be a bigger issue than it turned out to be. So we're just putting slight pressure on the build plate, not very much, and we're going to tighten these 4 screws up around the sides. And that should make it so this is just snug if I pull on it. Yep, cool. Alright, hit Z0. Alright, we've got it zeroed to the home position. So now I got to reinstall it all back in the enclosure and stuff and give it a test print. But I don't think I'm going to stream the test print part, just because it's kind of a messy process and I don't really have a good place for the camera for that. Yeah, that's that. So problem solved. And anybody else that might have this issue, what I'm going to do is raise that up a little bit. What I'm going to do is take that print file that I made for that piece. Yeah, it did work. And I'll put it on my printables page, which is actually linked on my Twitch page as well. So if you go to the About section, you can go to my printables page, but I'll put it up there and make it available for anybody that needs it. Maybe we'll chop this up and make a quick YouTube video on the issue. Thanks, buddy. Cool. Alright, well, I got some errands I got to go run, so I'm going to cut it here. But yeah, thanks for tuning in. Thanks for hanging out and checking it out. And I'll probably stream a bit later, play some games. So, have a great day. I'll see you later.